Alright, so do we have any grand ideas as to how to go about finding our solution for these two lines? Oh, and by the way, it does say to graph. So anybody got any great ideas?
Turn them both into y equals mx plus b and graph both of them.
Alright, so before I can do anything else, in order for me to graph, I have to have equations in the form y equals mx plus b. Do we all agree with that? That's the number one thing I have to do. So I'm going to take my first equation. Negative x plus 3y is equal to 10, and I'm going to solve it for y. What do you want to do?
Add x.
Add x to both sides. Those are going to cancel. Going to drop that down. It's going to leave me with 3y is equal to x plus 10. Have I solved for y?
No.
No. How do you propose we do that?
Divide by 3.
Where?
On both sides.
Everywhere. On all terms. Right?
Yeah.
Everybody agree with that? Okay. So, y is going to now be equal to a 1 over 3x plus 10 over 3. Everybody agree with that? Okay. So now I've got to do the next one. So x plus y is going to be equal to 2. Everybody okay with that?
Mm-hmm.
All right. I'm going to subtract x from both sides. And I'm going to get y is equal to a negative x plus 2. So far, so good?
Yeah.
Okay. So, let's then graph. Okay? So let's graph this one. It looks easier. We like it better, right?
Mm-hmm.
All right, so how am I going to know where to graph? I've got a slope that's a what?
Negative.
Negative 1 over 1. The negative 1 tells me to move down. The 1 tells me to move to the right. What's my y-intercept?
2.
2, which is where I'm going to start on my y-axis. Everybody agree?
Yeah.
So I'm going to start here at 2. I'm then going to proceed to move down 1 and to the right 1. If I didn't have enough room to continue to move down and to the right, what else could I do?
Up into the left.
Up and to the left. And then you're going to take your straight edge or your ruler and you're going to draw that line. Okay? Remember, to be able to function, you need to be able to operate at the highest level of maturity with your rulers. We are in 8th grade. Conversations about appropriate ruler usage should not need to be conversations I have with you. Okay? And remember, we're not just connecting the points, we're extending our line. Okay? Now, let's look at the other line. We don't really want to graph that one a whole lot, do we? Because what's our y-intercept?
A fraction.
It's a fraction. Our y-intercept is this ugly 10 over 3. And it's not even a good fraction. It's not even a fraction like that would give us like 1 1/2, right? Like it's a crappy repeating decimal fraction. Okay? It's like 3 1/3. Bleh. Alright? So we got to figure out another way at another point in order to make our graph work. Okay? So do we have any great ideas?
On the x-intercept.
Alright, so instead of starting with the y-intercept, why don't we just find the x-intercept and use it? Okay? And how do I find the x-intercept? I'll let what happen?
You have to solve for that.
When I'm finding the x-intercept, what do I let happen? I let y be 0. So do we all agree that I can come back to my original equation and I can let y be 0? So it's going to be 0. And you can actually go all the way back up to here if you wanted to. Okay, to the original equation and let y be 0. If you really wanted to. And that's probably easier because then you don't have to deal with your fractions. So if I came way back up here and I let y equal 0, do we all agree I'm going to find my x-intercept? Okay? So it would be negative x is equal to 10. Right? Everybody agree with that? And then it's going to be negative x. I got to get rid of my negative. So x would actually be negative 10. So what's my x-intercept going to be? Negative 10, 0. Agree?
Yeah.
Okay. But what's my slope still going to be? My slope would still be 1/3. Which means I would still come up 1 into the right 3. Okay? So if I start at negative 10, 0 and I'm coming up 1, that's going to be, or if I go right 3, that's going to be 7, 1. Negative 7, 1. And then I'm going to do it again, and that's going to be negative 4, 2. So my first point that I can fit on my graph would be negative 4, 2. Okay, you can probably have enough room to graph all of your points, right? Does it work that way? Calculate it for me. Start at 10. Start at negative 10, 0. And then go up 1 into the right 3. You end up on negative 4, 2 eventually. Yes? Did I do my math right? Okay. So then I'm going to keep going up 1 into the right 3 because what am I actually wanting to happen? I'm wanting them to intersect. So I'm going to go up 1 into the right 3, up 1 into the right 3, up 1 into the right 3. Okay? So then I'm going to want these lines to actually cross each other. That's my entire point here. No pun intended. Sorry, my graph's not weird. That's a really bad graph.
It's okay.
No, it's not, but
It's not okay.
okay. Okay. That's a little bit better.
That's
fine.
It's perfect.
Let's not kid ourselves. So what am I looking for? Taryn, what am I actually looking for?
The point where they both meet.
The point where they both meet. So what is that point where they both meet? It's right there. Agree? So that's going to be what? Negative 1, 3. So what happens at that point right there?
Or the point of intersection.
I agree that it's the point of intersection, but what happens at those 2 points? What can we say about those 2 equations? That they are equal. Sorry, you should speak louder. Okay, so if I am at this point right here, these 2 things are equal. Okay? Once I pass this point, one of them starts to become more expensive and more expensive and the other one does not. Okay? Up until this point, we would all agree that the red line would be the cheaper of the 2. Agree if we're talking in terms of money? because it's lower, right? At this point, they're going to cost me exactly the same, but then after this point, the red one becomes more expensive, right? Does everybody agree with that? Okay, so that's kind of how we think of it in terms of, well, what does this mean to me? Okay, but at that point right there, they're exactly the same. Everybody okay? Yes, no, I do. All right, so what I would like for you to do